I'm going to write down the addition formula for tan. So tan A plus or minus B is as follows. So learn this and then be able to apply it. In our case, right, we know that tan 30 is 1 over root 3. That's a value to learn. Tan 45 is 1. And tan 60 is then root 3. So we can get tan 15 if we use the minus and we use 45 here and 30 here. Remember, because we're using the minus, it's going to be a minus here. But then it's a plus here. And we've got everything we need. I've got fractions and surds going on. I'm going to multiply top and I'm not going to like rationalize the denominator yet or anything. I'm going to, because I've got like a fraction within a fraction, I'm going to times through by root 3. And now I think I'm going to need to rationalize the denominator. So we're going to get 3 minus 2 root 3 plus 1. And over here it's going to be 3 minus 1. And that is going to be 2 minus 2 root 3. So I can actually factorize that out. It's going to be 1 minus root 3 all over 2. Oh, wait, that's a mistake. That should be, that was 4. So actually this is 2 here. These will cancel. And I'm left with my 2 minus root 3. I think that's a pretty solid way of doing this question. Another way you could do it would be to use a double angle formula, tan 2a, and then let a equal 15. It's just that you're then going to get a quadratic that you have to solve, and you're going to have a 1 over root 3 in there. So that's actually how I did it when I did it originally. But I don't know, I kind of like this way. It's just simplifying surds once we get to here. All right, next part, we've got this trig equation to solve. And we're definitely going to need some addition formula again. Now remember, we're solving between 0 and 360. So this time I'm going to write down the addition formula for sine. We've got sine A plus or minus B is sine A cos B plus or minus sine B cos A. And so I can replace it in here. I'm going to get sine theta. Right, it's the plus one to start with. Hey, that might not look any better, but in fact it's a lot better because we don't want to be having theta plus 60 and theta minus 60 going on. Now I always remember like sine looks like this. We get to a half That's going to be sine 30, and then we get to a larger value, which is the root 3 over 2. That's what sine 60 is. And then cos 60 is the other one, it's a half. It feels like a good idea to, um, yeah, to substitute in for that at this point. Now this, we don't have to multiply the whole thing out because we basically have x plus y times x minus y. Like this bit here is the x and this bit here is the y. So you can hopefully see that. And that gives you a difference of two squares, f squared minus y squared. We're therefore going to get a quarter, because a half sine theta times a half sine theta is a quarter sine squared theta. And then minus 3/4 cos squared theta. This looks a little bit awkward at the moment. The first thing I can do is get rid of the fraction, a quarter. I'm actually going to multiply through by this 4, so it's going to become 4 minus 4 root 3. And then if I add this 3 cos squared theta to both sides, so before I do any identities, just try and get it as simplified as possible. I'm going to get 7 minus 4 root 3 cos squared theta. Now I don't need to use any I don't need to do 1 minus cos squared is sine squared, for example. I have sine squared on the left hand side and cos squared on the right hand side, so I can divide through by cos squared, which gives me tan squared. And another hint that you might want to do this is the fact that in the question, right at the start, we had that tan 15 is 2 minus root 3. To be fair, this is part A and part B. It doesn't necessarily mean the parts are going to link, but it is a good idea anyway. Now, admittedly, this does not look nice. How do we find that square root? There are a couple ways actually, but why not just try this 2 minus root 3 to start with? So 2 times 2, and then minus root 3 times minus root 3, and then 2 times root 3, but double that, give us the minus 4 root 3. So this square root actually is simply 2 minus root 3. That's very subtle. And if you don't see that, you could let a plus b squared equal 7 minus 4 root 3. And like, let's carry on and do it and sort of create an equation to solve a squared plus b squared plus 2ab Now what we can actually do is we can say that this part here, or these are going to be like the nice numbers because we're square like A and B, you assume are going to be potentially surds, but when you square them, you'll get back to normal numbers. So that must be 7. You can essentially equate the rational parts, and then we can also equate the irrational parts. And you can actually construct a quadratic to then solve. Now that's overcomplicating it, to be fair, but like if you didn't see, I'm not going to finish this off. It's actually also the standard way of finding square roots of um, complex numbers. So it is worth kind of trying it yourself. But I've shown you already in this case, we're going to get 2 minus root 3. So we're going to carry on from there. But one thing I've not done, I've just realized is, of course, what am I doing? When I take the square roots, I need plus or minus. So it's actually going to be plus or minus this thing here. Okay, we've got 2 minus root 3, which gives us a solution here. But remember, we're going all the way up to 360, and so we can just add 180 on. Now, if I've got the minus, then actually, because of symmetry, it's going to be down here. And it's going to be at minus 15 degrees, which is not in our solution range, but it is at least a starting point, because then I can add on 180 again to give me 165 degrees, or again to give me 345 degrees. Reject this one. And those are our solutions. Now that is not the only way of doing the problem. In fact, I've done it this way this time, but when I originally did it, um, I sort of combine it in a completely different way. Um, there is more than one way of doing it. Getting to cos 2 theta from here, or even sine 2 theta, like using the double angle formula is another option. In fact, let me show you how this works. So let's get it in terms of cos squared. I mean, that might be the natural sort of thing to do. So it'd be 1 minus cos squared is 7 minus 4 root 3 cos squared theta. And so we can actually add that on, and we're going to get an 8 here. And then I could even subtract that one as well. But let's just remember, and like now we've kind of dealt with that. There's another formula. So cos 2 theta, cos 2a is cos squared minus sine squared. We get 2 cos squared theta minus 1. That's another way of writing it. And therefore, basically, we can deal with that. We can write down that cos squared here. I can replace it. I can leave that 1 and divide by the 8 minus 4 root 3. gives me cos 2a. By the way, the reason I'm doing this is that if you were to square root this, that does not look very nice. Okay, you're not going to be able to do that without a calculator. Um, and why would we use double angle formulae? Well, it just means that we don't have to square root. That's the main reason for dealing with this. So cos 2a is going to equal 2 over 8 minus 4 root 3 minus 1. I can change that minus 1 to 8 minus 4. Actually, I'm not going to do that yet. I'm going to minus the 1. Right, this actually will simplify. So I can divide through by 2. So it'd be 1 over 4 minus 2 root 3 minus 4 minus 2 root 3 over 4 minus 2 root 3, which will give me 2 root 3 minus 3 over 4 minus 2 root 3. Okay, fair enough, it doesn't look very nice, but at least I'm not having to square root. Let's just see. Remember, we're expecting things to simplify because we know this is a non-calculator question. So I can rationalize the denominator by timesing by 4 plus 2 root 3. Which will give me 8 root 3 plus 4 times 3, 12, minus 12. Well, that is good news. Minus 6 root 3. So suddenly things are looking up. Divided by 16. And remember, this is a difference of 2 squares, so I just need to do this one times this one. 4 times 3 again, so it's going to be minus 12. Which is 2 root 3 over 4, which is root 3 over 2. And at that point, we are very happy because we can, root 3 over 2 is like a classic value for cos 30 is root 3 over 2. So I'm actually not going to finish this off. I'll let you do that. See if you can get the same solutions as before. I just wanted to show you how you could alternatively have done it. I mean, both are awkward. Let's be honest, because here you have to basically recognize, where's it gone? Recognize about the square root of that thing. And here you've got to kind of realize I don't want to use cos squared or sine squared, but I want to get it. Well, you can use them, but then you need to get it so you don't have a square root and get it in terms of cos 2a. Okay, we'll leave it there. Good effort.